In this video, we want to talk about partial derivative. Let's say we have a question that says, f x y equals x cubed plus 3x to the power of 3y squared plus xy. As we can see, this problem has multiple variables. In my previous video, we only have one variable, which is variable x, which is different from this particular problem that we have here. So, in order to differentiate this function, there is one question that we need to ask ourselves. And the question is, with respect to what variable are we differentiating this function? Is it with respect to y or with respect to x? If we are told to find f sub x, it means we are differentiating this function with respect to x. So in this case, y becomes the constant. If we are told to find f sub y, it means we are differentiating this function with respect to y. And in this case, x becomes the constant. So let us solve this problem. So f sub x becomes the derivative of x cubed is 3x squared plus 9x to the power of 2y squared plus y. And this is the final answer when we differentiate this function with respect to x. In some cases, we can be told to find f sub y. So in this case, x becomes the constant. So the derivative of x cubed is 0. The derivative of 3x cubed y squared becomes 3x cubed 2y plus x. We can further simplify by saying 6x cubed y plus x. And this is our final answer when we differentiate with respect to y. We can also be told to find f(x)(x). It means our first order differentiation, which is this. We need to differentiate it again with respect to x. So the derivative of 3x squared is 6x plus 18xy squared plus 0. y is the constant, so the derivative of a constant is 0. We can also be told to find f, y, y. So it means this first derivative here, we need to differentiate it again with respect to y. So in this case, our final answer becomes 6x cubed. X becomes the constant, and the derivative of a constant is 0. If we are told to find f, x, y, it means this first function here, this first derivative, this first result here, we need to differentiate it also with respect to y. So if we rewrite it here, 3x squared plus 9x squared y squared plus y. If we differentiate the function with respect to y, 3x squared becomes 0, followed by 9x squared 2y plus 1. So the final answer becomes 18x squared y plus 1. And this is our final answer for this problem. We can differentiate also by saying y, x. We end up with the same answer. So if we differentiate with respect to x, this time period, which is this result here, we have 6x cubed y plus x. With respect to x becomes 18x squared y plus 1. And that's the final answer for this problem. You can see it is the same as this. So let's move to the next question. Okay, for simplicity, let's cut some things out at this point. Problem 2. Let's say we have f x comma y equals e to the power of 2x squared plus 3xy plus xy. So in this case, this is an exponential function, and it will be treated as chain rule. So if you've forgotten how to differentiate a function using chain rule, I will advise that you check my previous video in that regard. So in this case, let us recall that the derivative of e to the power of x, let's say, let me put it this way. The derivative of e to the power of x, if we have a function EX. F prime X is the same as EX, EX rather. If we have Fx equals e to the power of 2x, in this case, f prime x becomes the derivative of the inside function multiplied by the derivative of the outside function. The inside function is 2x, which is at the top. So derivative of 2x is 2 multiplied by the derivative of the outside function, which is the same as e to the power of 2x. So the final answer becomes 2e to the power of 2x. So this same method here, we will apply it to the question. Of course, you can be asking that the derivative of e to the power of x, the inside function is x, the outside function is e to the power of x. So f prime x in this case is the derivative of the inside function, which is x, is 1, multiplied by the derivative of the outside function, which is e to the x, is nothing but e to the x. So that is how I ended up with e to the x as this. So let's solve the problem now. In this case, the inside function is what we have as the power. The outside function is the whole problem. So the derivative with respect to x of the outside function is the same as the question, 2e to the power of 2x squared plus 3xy plus xy multiplied by the derivative of the inside function, which is the power with respect to x. We have 4x plus 3y plus y. So finally, we have 4x plus 3y plus y, all in parentheses, e to the power of 2x squared plus 3xy plus xy. And that's the final answer for this problem. If we are to find it with respect to y, the same thing, the outside function is e 2x squared plus 3xy plus xy multiplied by the derivative of 2x to the power of 2 is 0, followed by 3x plus x. In this case, 3x plus x, we have 4x. E to the power of 2x to the power of 2 plus 3xy plus xy. And that's the final answer for this problem. So let's move to another problem. In a situation where we have a question that says f, open parenthesis, x, comma, y, comma, z equals x squared plus y squared plus x, y plus x, y, z plus 4z. In this case, let's differentiate with respect to x. So we have 2x plus the derivative of y squared in this case is 0. So followed by y. So I'll take this back. So shift somewhere. So followed by y plus yz plus 0. So this is the end result if we differentiate the function with respect to x. So what if we differentiate with respect to y? So we have f sub y. The derivative of x squared is 0. So we have 2y plus x plus xz. And the derivative of 4z is 0 in this case. So this is the end result. So if we differentiate with respect to fz, the derivative of x squared in this case is 0. The derivative of y squared in this case is 0. The derivative of xy in this case is 0. The derivative of xyz in this case is xy plus 4. That is the final answer for this problem. So we can further do, we can do some second derivative for this problem. If we are told to find fx, that means we have 2x plus y plus yz. If we differentiate it with respect to x again, we will have 2. And that is the final answer. If we differentiate, if we say f, y, y, we have it back again as 2y plus x plus xz. So differentiating it again, we have 2. And that is the final answer. For fzz, Differentiating it twice, we have the first order differentiation as x, y plus 4. Now, what is FZZ? What is the final answer? As you can see, there is no z variable in the first order differentiation. So in this case, the derivative of xy, which is a constant, is 0. The derivative of 4, in this case, is also 0. So in this case here, our final answer becomes 0. And let us see if we can do some mixtures here. If we can mix some questions together. Fxy becomes what? Feel free to pause the video and try it. So in this case, the first order differentiation is with respect to x is 2x plus y plus yz. Now, with respect to y, it becomes the derivative of 2x is 0. The derivative of y is 1, followed by z. So this gives us the final answer for fxy. For fyx, you realize that we have the same answer. So let's try it. We have 2y plus x plus xz. Our end result with respect to x, 2y becomes 0. The derivative of x is 1 plus the derivative of xz is z. As you can see, we have the same answer at this point. Let's try fzy. Fz is nothing but x, y plus 4. Finding that's the derivative of that function, of that result, with respect to y, will give us x. If we find it also, if we switch it and say that fyz, are we going to have the same answer? Let's try it. So fy is 2y plus x plus xz. So differentiating these with respect to z, 2y becomes 0. X becomes 0. Xz becomes x. So as you can see again, we have the same answer. So you can try others yourself. You will realize that at some point, we will get the same answer when we switch variables. So let's try some other questions. If we have a question that says f x comma y equals x squared plus 4y all to the power of 2. Of course, this is also known as a chain rule question. So we are to differentiate this function rather, using chain rule. So let us differentiate it with respect to x first. The derivative of the inside function and the outside function is what we are to determine. Let's start with the outside function. Of course, the outside function is the whole function that we can see. So the derivative of the outside function is nothing but 2 open parenthesis x squared plus 4y close parenthesis, and that's it. But what about the inside function? The inside function is what we have in the parenthesis, which is x squared plus 4y. So if we are to differentiate the inside function with respect to x, then we have 2x rather. So in this case, let me put it in parentheses also for simplicity. And at the end of it all, we have 4x open parenthesis x squared plus 4y close parenthesis. And this is the final answer when we differentiate with respect to x. Now for this same problem, let us differentiate with respect to y. And let's see our final answer. So if we differentiate with respect to y, the derivative of the outside function is still 2 open parentheses x squared plus 4y close parenthesis. So with respect to y becomes 4. So our end result will be 8 open parentheses x squared plus 4y close parenthesis. And that is the final answer. You can choose to open the parentheses if you want, and you can leave it like this also. It's still the same. So let us move to the next and the final problem. So in this case, let us tackle a trig function. Let's say we have a function that says x comma y equals the sine of x plus 2xy plus x, y plus, sorry, let me take this back. The question was, all right. Plus y at this point. Let's stop here and let's see what this will get us to. We have the outside function, which is sine with what we have in the parentheses. The inside function is what we have in the parentheses alone. So differentiating with respect to x, the derivative of the outside function, which is sine of what we have in the parentheses, sine of x plus 2xy plus y. What is the derivative of sine? The derivative of sine is cos. So let's repeat what we have in the parentheses. Now, what is the derivative of what we have in the parentheses with respect to x? So in this case, we have 1 plus 2y. So along the line, and finally, we have open parenthesis 1 plus 2y close parenthesis cos open parenthesis x plus 2xy plus y close parenthesis. And that's the final answer if we differentiate with respect to x. What if we differentiate with respect to y? Also, our first expression is cos x plus 2xy plus y close parenthesis. So with respect to y, or the inside function, the derivative of x in this case is 0. The derivative of 2xy is 2x. And the derivative of y is 1. So finally, we have open parenthesis 2x plus 1 close parenthesis cos open parenthesis x plus 2xy plus y. And we have the final answer. So let me give you some exercise to try during your free time. Let's clean some things up here. So, number one, let's say we have fx, y cos 2xy plus 4xy. Sorry, let me just erase some stuff here. 4x. Let's keep this short. And f x y equals tan, open parenthesis, x plus y plus x y plus 4x, close parenthesis, f comma y equals e to the power of x y plus 10x before f x comma y comma z equals 2x plus let's say we have 10xy plus 20xyz. Fine. We have f open parenthesis x y z equals sine of y z plus 3xy plus 5xyz. So for these questions here, kindly find fx, fy, and fz. And that's it for this video. Thank you so much for watching. Have a great day.